What's up, everyone? I hope you're all having a good day. This video is going to be the first video part of my new series where I will show you how to build your own home lab so you can use it as a testing environment or any project. I personally used this exact lab as part of my upskilling when I was working as a system administrator, and I continue to use this as part of my current role in cybersecurity. I am a firm believer that having your own home lab for testing and validation is a must. So the first question I would like to address is the for who. I don't think this is an extensive list of exactly who would fit in, who would benefit from this home lab, but some that I have listed are SOC analysts, threat hunting, incident response, forensics, purple, red, and blue teaming. From engineering aspect, there's infrastructure, cloud engineering, system admin, and network admins. Again, not an extensive list. There's a lot of other roles that would fit in, but just to list some roles that would benefit from this, here it is anyway. And another topic to talk about is what will we actually build? So in this video, I'm going to focus strongly on networking just to show you how to set up the initial networking, and then we'll focus on other topics, maybe even backups, set up your own SIM, log in, forward to the SIM, setting up detections, setting up your own cyber range. Yeah, there's a lot to cover here. I don't want to really go too much into detail, as that would turn into a full 10-minute video just covering the topics that I would like to cover in this series. But for today, we're going to focus on networking. Specifically, in this lab, what I'm going to use a firewall, which is a SonicWall TZ400. It doesn't really matter. You can pick up any cheap firewall you find online. Essentially, like firewalls do differ vendor to vendor, but in its core, for most part, they all do the same thing. So it doesn't really matter which firewall you pick out. I do recommend SonicWall. They're relatively cheap and they are intended for small to medium market and especially home labs as well. They work perfectly. A switch, again, doesn't really matter. I would just say you should get a managed switch so you can log into the management interface and configure it as you wish. In my case, I'm using a HP switch, which is a layer 2 managed switch. Using the firewall and the switch, we're going to configure some IP ranges, a DHCP scope, a VLAN. I'll show you how to set up a trunk port and the difference between a tagged and untagged ports. And then the next topic I'm going to cover after this video that's also part of networking is going to be how to set up an access point and set it up within the access point. We're going to set up two networks, one guest network and one LAN. And this is where we're going to connect up inter VLAN communication, and I'll show you some firewall rules as well. And we'll go a little bit more in depth in further videos when it comes to networking. I think for an intro, this should be more than enough. I want to heavily focus on these videos to be more hands-on rather than just covering theory. So let's just jump straight into it. I'm gonna start from the very start and we'll get this configured. This is the firewall that I do have in place here, and the first thing I did is I clicked into the reset button here and I reset the current configuration that I have. When the firewall boots back up, it's going to wipe out all the configuration that I had, and it's going to reset its IP address of the interface to 192.168.168. And for us to communicate with this firewall, we need to connect our computer into the firewall. And the port we need to connect to is the one that says LAN. Now, if you don't know the difference between LAN and a WAN, just to keep it simple, I'll say this. The LAN port, we're going to use it to connect into the switch, and the WAN port will be connected to the home router. Now that we have connected into the firewall, our computer is not going to get an IP address from the firewall because we don't have a DHCP server configured. So what we need to do is we need to set a static IP address within this range so we can communicate with this IP address, which is the firewall. Now, if I go into IPA, this is the network card I am plugged into, and as you can see here, it is up, but it's not receiving an IP address. And these are all my network connections. I created a network, profile called USB-ETH. This is the interface and the connection I'm going to use to set a static IP address. I'm going to do nmcli modify, connection modify. And so 192.168.168.2. It doesn't really matter as long as it's not .168 as well. The gateway, let's point it to the firewall, 168.168. And this is the default IP address. It depends on the vendor of your firewall, but they should specify in the documentation what the default IP address is of the firewall. DNS doesn't really matter. We won't be able to reach it because we don't have the WAN port connected into the router. IPv4.method manual, not auto. Okay, and what we need to do is connection up. Let's run IPA, and we have the IP address. So just for a sanity check, let's ping the firewall, and we can reach it. Let's get logged into the firewall. The default username is admin, and the password, I believe it's admin2. Nope, admin password. Yeah. So the password is just set the password. The first thing we're going to do once we get signed in here, we're going to update that password. And this is under manage and base settings. The administrator name. Usually I would get this updated, but now I will do this after I complete the video series. Let's put in the old password and the new password. I already have a record of this in my password manager. If you don't have a password manager, get one. And let's get that updated. I think that's gone through. It's a quite an older interface. Again, you don't for this type of labs, you don't need to buy the newest equipment. Just get something to get experience. Like in general, a lot of the stuff doesn't really change all that much. The core concept of it remains the same. Right, what's the first thing we're going to look at? Let's go into networking and interfaces. This is where we're going to get to see the current interfaces. Now, the one which is on X1, we can see here it has no IP address. That means we have no router plugged into it. The first thing I'm going to do is I'm going to plug in my internet router into the SonicWall. And from the internet router, you can plug it into any LAN port. And from the LAN port, we'll plug it into the X1, which is for the WAN. If you can see a little bit better on this image, this is the port we're going to select, the 1X1. Back in our firewall, we are seeing the X1, it has a connection now, and we actually got an IP address from the router. Moving forward now, all the devices on the LAN interface are actually going to be able to reach out to the wide network. The first thing we're going to do is we're going to update the interface's IP address. So right now we're reaching the firewall on this IP. We want to change it, and what we'll do here, we'll click the edit icon over here. We're going to keep it as a static IP mode, and let's change the IP address to 10.0.10.0.1. The subnet will remain, the default gateway, no need. Let's call it native because it has no VLAN. Now this should crash on us once the change goes through because the IP address is no longer 192.168.168.168, and that's the interface we're communicating with right now. Right, I forgot. The next thing we need to do here is because the IP address is changing, our IP address is also on 192.168, meaning that we need to update our IP address to be on the same IP range as the LAN. And the reason we're not automatically getting an IP address because we don't have a DHCP scope configured. So now when our device is reaching out to the firewall asking for an IP address, it doesn't get one. So we need to assign this ourselves again. Again, it doesn't really matter which IP address as long as it's on the same range. Once again, let's point it to the firewall. Doesn't matter. Actually, it does now, because if we point it to the Google DNS, we will be able to reach out since we plugged in the one. Let's check. Actually, we forgot we have to turn the interface back. Okay, so now we have a new IP address, and now when we reach out to 10.10.0.1, we should be able to reach our interface, our firewall. Just to give you a visual of what we're trying to achieve here, I'm going to set up a couple VLANs here. In this example, I have VLAN 10 and VLAN 100. Essentially what this means, every device that will get tagged with VLAN 10 on the switch is going to communicate back to the firewall, and it will receive an IP address that we're going to configure a scope for this subnet, 10.10.10.1. And same thing we're going to do for VLAN 100, and I think we might create VLAN 20 as well. So the top interface is native and untagged, so this is not part of any VLANs. If we want, for example, VLAN 10 to be able to reach VLAN 100s, we'll have to create some rules. And if we create some rules that allows VLAN 10 to communicate with VLAN 100, it doesn't mean that VLAN 100 will be able to reach VLAN 10. Once we start configuring this more, I hope this will make a lot more sense. Again, I'm not trying to cover the theory too much. I'm just trying to do more practical work and actually show you how to configure this stuff. Back in the firewall, let's go here where it says add interface, and let's add another virtual interface. The zone, it's going to be LAN. VLAN tag, let's go with 10. Parent interface is X0, this is the first LAN. Static mode, and IP address. So what I like to do is I like to set the third octet to match the VLAN. Obviously, if you have a much larger network, that might differ hugely, but for this case, this is fine to do. Subnet is fine, the default gateway, we don't need to specify it, as the interface we're configuring here is going to be the default gateway for other devices, really. Let's call this the management interface. Management LAN maybe will fit this better. I think there's an error, I'm not sure, I didn't really read. Okay, that's perfect. Let's create another interface. Actually, the idea that I had in place, VLAN 10 is going to be the LAN. I'm going to create VLAN 1, which will be used for management. So the device that I'm currently signed into, this is the one that probably the only device I'm going to use for this VLAN, to be honest. 10.10.1.1, again, subnet and management LAN. Let's create one last one. Just wanted to highlight the VLAN tag. It can be any number really. Maximum 4094. 10.10.100.0.1. And this is going to be guest network LAN. The next thing we're going to focus on are DHCP scopes. The idea behind it is when a device gets connected to the switch, we will dedicate some ports belonging to a certain VLAN. And when you plug a device into that port, it will get tagged, it'll tag all its traffic with VLAN 10. And when that arrives into the firewall requesting for an IP address, the firewall is going to give out an IP address that's on this range. We need to configure the DHCP scope on here by going into the DHCP server. Looking at this screen, we have a couple settings here. First, I just wanted to point out at the very bottom, we see the current leases. So this will show you all the devices that are currently connected to your networks using the DHCP feature. And just above is where we get to configure our scopes. I wanted to kind of talk about the difference between a dynamic and a static scope. A static scope is almost equivalent of setting a static IP address on a device. So if you have, for example, a printer that you want to at all times be on one specific IP address because all the users will connect to that printer using an IP. This kind of works the same way, except you don't configure it from the device, you configure it from here. And what you would do is you would assign an IP address that you want that device to have. So let's just say 10.10.10.100. And then you would specify the MAC address of the device. So anytime a DHCP request would come to this firewall, it would see the Ethernet address, which is the MAC address of that device. And once it recognizes, it'll apply the IP address we specify here. There are some scenarios where this works out, but a lot of times admins would just choose to set the static IP address on the device itself. For our case scenario here, we're going to set up a dynamic range. And the way this works is we can specify the starting IP address and the ending IP address, meaning that anytime a DHCP request comes asking for an IP address, it will give one belonging in this range. So let's do VLAN 10 first. I'll do 10.10.10. And let's start for the 10th octet. So this will allocate 20 addresses for the DHCP. which should be more than enough for the amount of devices that I plan on configuring for this slab. The default gateway, let's point it to the interface of the firewall of this subnet. And this is for the default LAN. I will also quickly configure a dynamic range for the VLAN one, which we have allocated for management devices. Let's just do a really small one, 10.10, sorry, .1. Let's start from .2, and maybe let's go to .6. And this is something I wanted to point out as well. When you configure a DHCP scope, if you ever have a device that you want to put a static IP address, what you should do is you should put a static IP address outside of this DHCP scope. So for example, earlier we put an IP address, a static IP address 10.10.0.2. Let's imagine for a second I've used this subnet. So instead of .0.2, it was .0.1.2. That means that there is actually a chance that the DHCP server would hand out the IP address 10.10.1.2 to a device that plugs into the switch, causing a conflict between the two IPs. Just something to keep in mind. If you are setting static IP addresses, make sure it's outside of the DHCP scope. We have the firewall configured, we have the IP ranges, we have the DHCP scope. The next thing we're going to look at is the switch. At this moment, the X0 interface, I have that plugged in directly into the computer. From now, what I'm going to do is I'm going to plug that out and I'm going to plug the X0 cable into the switch. Another visual of this that hopefully allows you to understand it a little bit better. So let's look, this is the ISP router, and you can select any of the LAN ports and connect it into the one port on the firewall, and then the switch is going to connect into the LAN. And this will be a trunk port. Now, what is a trunk port? In a super simple terms, it just allows us to carry multiple VLANs over a single cable. And if we're doing VLAN networking between a switch and a firewall, the uplink connection is going to be a trunk. I will also show you a couple photos of how this actually looks physically. From this photo, you can see the red cable is going into the switch, which is the LAN from the LAN port, and the blue cable is going in from the switch into my computer. Now, as a pro tip, I would recommend if you have the ability to just color mark your network cables. So anything that's sensitive, I usually use a red cable, and anything that's just LAN or data connection, I'd use a blue cable. It makes it a lot easier if you are in a work environment and you need to troubleshoot when you're, let's say, inside a comms room or something. A lot of them can get super messy, and having this color code could save you a lot of headaches. But that's kind of outside of the scope of a home lab, let's say. All right, now that we're on the switch here, the first thing we need to do here is we need to set the port 1, which we're using as an uplink between the switch and the firewall. We need to set that as a trunk port. And the way we're going to do that under interfaces, let's go into port info and config. Again, the steps here is going to be highly dependent on what switch you have. Every vendor has a different implementation of this. And this one in particular is actually an old switch anyway. There's also two ways you can do this. You can do it through a GUI interface like I am doing now. You can also do it through a command line, CLI. The CLI in general is going to be a lot faster, but just for simplicity's sake, let's just do it in GUI. I will be making a separate video outside of this that will show you how to set all of this up using CLI as well. The first thing I like to do here under port properties, let's click change and let's add a port name, firewall X0. Set the trunk name, the trunk type, the trunk, and assign it to trunk group 1. Now, I think it's a good practice to assign names to the port. So if you are managing this remotely, you or whoever else is working on it can know what port this belongs to. But again, unless you configure it or you know somebody that did, take this at its face value because you don't actually know for sure if it is going to firewall X0. It could be very common that somebody changes the port, maybe moves the X0 to port 7 one day, and they'll never update this. So never, just because you see it here, it does not mean it's true. That's just a warning from some experience I've had with this. Right, let's start configuring our VLAN. Let's jump into VLAN management, add a new VLAN, and this is going to be VLAN 10, which is the LAN, the default LAN. This is where we're going to configure untagged ports and tagged ports. So port 1, our uplink port, should be tagged, which is a trunk port. In this case, I will be allocating some ports that belong to VLAN 10. And the way we can do it is by going into VLAN 10 and setting those ports as untagged, meaning when they arrive to the switch is not expecting these ports to be already tagged, meaning that the tagging will be done by the switch itself. If you set it to be tagged, you're telling the switch that the traffic arriving from that port already has a VLAN applied to it. So it'll just ship it to the firewall. And you can only, if you specify it on VLAN 10, let's say port 13 to be untagged, that means you cannot set it as untagged in VLAN 1 as well. I'm showing you an image of my switch here, and this is a pretty big switch. It's a 48 port, and it usually comes with a couple blocks, and in this case it's coming in with a block of 12 ports. 12 ports, and the block I'm looking at is between port 13 to 24. Now, if we were to configure this using CLI, I would configure these straight away, but using GUI, it's a little bit tougher as you have to do one port at a time, especially in this interface. Now, if you were using CLI, you could just specify ports from 13 to 24, put them all untagged under VLAN 10. But in this case, just to show you the concept, I'm just going to configure one of the ports, which is port 13. So under ports, let's select change. First, let's do port 1, change it to tagged. We need to click save. Back into VLAN 10, we can see the tagged port 1. Down lower, we can see the group trunk 1. This is also important for HP switches. We need to mark that as tagged as well. Quick refresh. As you can see here on the ports, we have tagged 1 and trunk 1. Back into VLAN 1, we need to have the exact same for port 1 and the group. We'll mark that as tagged. And we'll mark the group tagged. Let's just confirm it. Tagged port 1 and trunk 1. Untagged. So right now, VLAN 1 is dominating all the ports, and VLAN 10 only tagged ports. Perfect. So now let's allocate our port 13 and let's set it to untagged. So this means when the switch receives a connection on port 13, it will tag all of its traffic with VLAN ID of 10. There we go, untagged 13. And if we go back into VLAN 1, we can see that now the untagged has changed. You don't have to make this change yourself. Every switch that I've worked in, it automatically will change it for you. So you can see here 2 to 12 now is untagged, 13 is skipped, and everything else past 13 is also untagged in VLAN 1. For this video, I'm not going to configure the VLAN 100. We'll look at this later once we have the access point actually configured as well. Something I forgot to point out earlier, I forgot to add access to the management interface on these two VLANs. So all the devices from VLAN 1, VLAN 10, and VLAN 100 could not communicate with the firewall interface, which in general is fine. And it's probably the concept that it's something that you should be implementing, but obviously for Homelab, especially the management VLAN, should be able to reach the management interface. So what I did is I updated this. On the management, I added the HTTPS. I also added ping just for sanity checks. I always like to be able to reach the firewall using ping. Now I've done the same for VLAN 10, but I did not put this in motion for the guest network VLAN 10. It's very rare. At least you should never see this in place for a guest network. The guest network should have as little access to the environment as possible. Okay, now I've connected this laptop here into port 13, and I can already see here that it's picking up a network connection. So what we can do here is we can check IP config, and we can see here the interface is picking up the IP from the VLAN 10. So this is the range we configured for the DHCP scope as well, between 10.10.10.10 to 30. And we're getting an IP address with .27. And I just wanted to highlight this from last time as well. If you want to set a static IP address, you just go ncpa.cpl. In here, you find your Ethernet connection, properties, and then IPv4. So we could set it statically. Let's just, in this case, let's set it statically and let's set it to .9, just outside of the DHCP scope. The default gateway. Okay. I am connected over RDP, so this could crash. And the connection is back online. And now we have the static IP address of 10.10.10.9. Just to wrap this up, we've tested the DHCP, it's working, and the VLAN is assigning the correct IP address. So today we've configured a VLAN on our switches. We have some IP ranges and DHCP scope and configured on the firewall. This should serve as a good intro in the practicality of networking. Again, this is going to be a super small network, but it does help you put together the pieces rather than just reading the theory. It's good to see it. And if you can get your hands on a switch or a firewall, you'd be surprised how many people out there would give away this stuff for free as long as they know that you're using it for learning. And before I end the video, let's just have a look at our current diagram. Right now, we only have 3 devices here. We have the ISP router, we have the SonicWall firewall, and we have the switch. So this is all configured, and we have 2 VLANs. Well, we have 3 to 100, but there's nothing going on there, so I'm just going to leave it out of the diagram for now. In VLAN 1, we have a static IP address set on the Linux desktop. So this is this host managing used under the management LAN. And we have a host on VLAN 10 as well. So this is the Windows laptop we saw, and we set a static IP address. I've also specified the DHCP scope here, so maybe just to match this as well, let's do it here too. And I believe it's just 2.6. I hope you guys enjoyed the video. If you found the information useful or if you have any questions, feel free to drop in the comments. I'll be sure to respond. And outside of that, until next time, I'll see you.